Hey guys, it is Robert, aka Basforne here, and today I am going to give you guys a video on the Rhode Mathematics League state playoffs from 2012, April. I don't know if we are going to go to the States this year because of this coronavirus, but I really want to prepare you guys just in case, and I really want you guys to have more practice. This is for Prout Math Team and anybody else that really wants practice with this, and I really recommend that you try the problems first. I will put timestamps to all the rounds and individual problems, and I will post any errata, aka if anything's wrong, in the description. Again, I really do encourage that you try these on your own, and yeah.
Alright, so we're going to start with arithmetic and number theory. So the first question is, how many digits appear in the expanded product of 4 to the 22nd times 125 to the 13th power? So this might look like, obviously, it's not going to be some massive product that you're going to have to multiply out. But we can realize that 4 and 125 are both powers of smaller numbers. In fact, 4 is really 2 squared. So this is 2 squared to the 22nd. Times, well, 125 is 5 cubed. If we find its prime factorization, 5 cubed to the 13th. Okay? Now, when we multiply, because it's an exponent to an exponent, it's going to be 2 to the 44th times 5 to the 39. And we can take out 39 of these. It's really 2 times 2 times 2, 44 times. So this is really 2 to the 5th times, and then in parentheses, 2 to the 39 times 5 to the 39. When we multiply the bases, because we have a exponent, we get 2 to the 5th times 10 to the 39. What this really is I'm multiplying 10 x amount of times, 39 times. This is the same thing as 39 zeros at the end. And we know 2 times 5, or 2 to the 5th is going to be 32. So really this is 32, that number 32, followed by 39 zeros. In the end, the number of digits, those are those single numerical values, it's going to be 41. So number 2, when simplified, the fraction a over b is equivalent to 3/4. If the numerator is decreased by 1 and the denominator is increased by 2, the resulting fraction is equivalent to 2/3. What is the value of b? So, this is more algebra than arithmetic and number theory, to be honest with me. So, you know the fraction a over b is equal to 3/4. That's the easy part. So the numerator is decreased by 1. That means the top part, this number a, is going to be decreased by 1. So a minus 1. And the denominator, the bottom number, is going to be increased by 2. So this is b plus 2. And this is equal to 2/3. And woohoo, we got a system here. So we got to solve the system somehow. So what I'm going to do here is I'm going to solve, and we get 4a is equal to 3b. We'll just keep it there for now. Maybe we can do something with that. Who knows? With here, we'll get 3a, 3 times a minus 1 is equal to 2 times b plus 2. So 3a minus 3 is equal to 2b plus 4. Well, maybe we want to solve for a and b. I was thinking maybe 3 and 4, some type of multiple, 2 and 3, no. So we're just going to solve. So a is equal to 3/4 b. Dividing both sides by 4. That is what we get. So what we do is 3 times 3/4 b minus 3 is equal to 2b plus 4. So then we get 9/4 b minus, well, really, let's just set it equal to 2b plus 7. I'm bringing that constant over the one side. Then we're going to go up. And we get 9/4 b is equal to 8/4 b, because 8 over 4 is equal to 2, plus 7. So we get 1/4 b is equal to 7. B is equal to 28. Alright, number 3. The base 5 number 3212 base 5 is equivalent to a base 10 number k. How many positive integral factors does k have? So, we're usually used to base 10. That's what we call our number system, base 10. But here we have base 5, and you're like, well, how are we supposed to convert it? And this is where we're actually going to consider the value of each of these digits. So, just a little recap. Let's say I have a 2-digit number in base 10. 2-digit number in base 10. Let's call it AB. B is going to have value B. It's the 1's digit. But A is the 10's digit. For every numerical increase of A, we're really adding 10. So this is really 10A plus B. Think about it, 26. 10A, 20 plus 6, 26. So, we can kind of do the same thing here. Converting from base 5 to 10 is just considering that. So really, 3, 2, 1, 2. We're going to put a little underline of each digit. Really what this digit is the value 5 to the 0 power. This is really 5 to the first, 5 to the second, 5 to the third. Just like in base 10, 10 to the 0th is always going to be 1. 10 to the first is going to be 10. 10 to the second is 100. That's where you get the hundreds digit from. Kind of the same thing here. This is the really 125th digit, 25th digit, 5th digit. These numbers are telling me, well, how many times do I need to include 5 to the 0th and so on. So, 5 to the 0th is 1. So, this is just 2 right here. Here we have 5 to the first. We're only using it one time, so this is really 5. 5 squared is 25. Twice is going to be 50. And then 5 to the third is 125, plus 3 is 375. So we just need to add all these up. In doing so, we get 432 in base 10. Now, we need to find the number of positive integral factors. An integer is just any whole number. Positive just means not negative. So 432. What we want to do is we want to find its prime factorization. Therefore, a product of numbers such that we can't break it down anymore. So I'm noticing it's divisible by 2. And obviously it's true. And this is 216. We can break it down even more. This is 2, 108, 254, 2 and 27. 27 we know is going to be 3 times 3 times 3. So the prime factorization is going to be, we have 1, 2, 3, 4 4s and 1, 2, 3 3s. So 432 is 2 to the 4th times 3 to the 3rd. So this is going to help us determine the number of factors because we can just look at these exponents. The number of factors is going to be each exponent. So number of factors is going to be the exponent plus 1, exponent plus 1, so on and so forth. So we're going to take the 4 here. I don't care about the base, I just care about the exponent and add it by 1. So 4 plus 1 times, we're going to take this exponent and add it plus 1. So 3 plus 1. So simplifying, we get 5 times 4. This is the number of factors, which is 20. You could also actually look at how many factors there are and do it all out, but this is just a little shortcut. Okay, so now we're in stats, probability, and matrices. They actually used to have all 3 in the same back in 2012, and as of this year, well, it's just stats, probability. So nonetheless, the first question is, n is a 2x2 matrix whose entries are 1, 2, 3, and 4. What is the largest possible value for the determinant of n? So this is just a little recap, as I did in the last question. Sorry if this marker's not really that great. So let's say I have the matrix A, B, C, D. The determinant is going to be AD minus BC for any 2x2 matrix. So if we want the largest possible value, it kind of makes sense we need to maximize AD and therefore minimize BC. So to maximize AD, well, we're going to take the 2 largest values here, 4 and 3. So this is going to be 4 times 3. And then it doesn't really matter what order we put the other 2 in because it's commutative. And the answer is 10. Alright, so number 2, Find out solutions of the equation ax squared plus bx minus c equals 0, where a is the median, b is the range, and c is the mode of the following set of data. 7, 6, 4, 5, 4, 7, 9, 6, 4. Express your answer in simplest form. So, whenever I have a set of data in statistics, I always arrange it from least to greatest. Because this will help me to better find the mode or median. It just makes my data a lot more easily to see. So 4 is 3 times, 5 once, 6 twice, 7 twice, and 9. So we're going to find A, B, C. So A is going to be the median. There's 9 values in the set, so it's going to be the 5th value right in the middle. Because notice it's symmetrical. There's 4 values to the left, 4 to the right. So A is 6. B is the range. Oh my, I'm sorry, my 4 is cracking. The range is going to be the largest minus the smallest. So 9 minus 4 is 5. And the mode is going to be the one that occurs the most in the set. And there's 3 4s, so it has to be 4. So we get the quadratic, 6x squared plus 5x minus 4 equals 0. And we can factor, and I'm going to guess this is factorable, but I'm not sure. I'm just going to play it safe and use the quadratic formula. So negative 5 plus or minus square root of b squared, which is 25, minus 4ac. A is 6, c is negative 4, over 2a, which is 12, because 2 times 6. Negative 5 plus or minus square root 25 minus, well, this is going to be 24 times negative 4 is 96. So this is really 25 plus 96 over 12. This is going to be 121, and that's a perfect square because it's 11 times 11. So really this is negative 5 plus or minus 11 over 12. And we can simplify. We can take the plus or the minus. So negative 5 plus 11 over 2. Negative 5 minus 11 over 2, not 2, 12, I'm sorry. And we can just find each of these values. So we get 6 over 12, which is 1/2. Negative 16 over 12 divided by 2 or 4, you get negative 4 over 3. These are your 2 values. You could put x equals at the front, doesn't matter, but you should be getting 1/2 and negative 4/3. All right. So number 3, a number is chosen at random from the 75 smallest positive integers. What is the probability that it is a prime number? Express your answer as a fraction in simplest form. So A and B are relatively prime if it's A over B. So don't be afraid to actually write them all out. I'm not going to write all of them out, but I'm kind of use process of elimination. The 75 smallest positive integers, those are those natural numbers, the counting numbers, 1, 2, 3, 4, all the way to 75. So this is 1, 2, 3, 74, 75. And we need to see what's the probability that it is prime. Prime numbers are just any numbers that only have 2 factors, 1 and itself. And this is important, and I've seen some of you make this mistake. 1 is not prime. It is not prime because it only has 1 factor, and that is itself, which is 1. It's 1 and itself. They have to be distinct. So that's why 1's not prime. And 2, guess what? 2 is actually prime because look at 1 times 2. And you know what? That actually is pretty nice. So here's the thing. What's the probability that it is prime? Well, prime numbers out of these are only going to be odd. Why? Because any even number besides this is not going to be prime because that has that factor of 2. So, for numbers greater than 2 and even, this is not prime. So we're only going to consider odd numbers. I mean, why not? This is going to be prime. So we're just going to consider all the odd numbers, and we're going to count them all out. 3, absolutely, it's prime. 5, absolutely. 7, absolutely. 9, well, that's not prime. 3 times 3. 11, absolutely. 13, absolutely. 15, nope. 3 times 5. 17, absolutely. 19, absolutely. 21, nope. 3 times 7 doesn't work. 23, absolutely. 25, nope, that's a perfect square. 5 times 5. 27 does not work. 3 times 9. 29 does work though. 31 works. 33 does not work. 3 times 11. 35, and you multiply 5, does not work. 37 absolutely does work though. 39, 13 times 3 does not work. 41 does work. 43 works. 45 doesn't work. 9 times 5, or 3 times 15. 47, that does work. But 49 does not work, because it's 7 times 7. 51, this is a tough one, actually does not work, because 3 times 17. 53 does work. 55 doesn't work, because 11 times 5. 57 is 19 times 3. 59 does work. 61 works. 63 does not. 9 times 7. 65 obviously doesn't work because it's divisible by 5. 67 I think works. I gotta just make sure. 69 does not because 23 times 3. 71 works. Yeah, it does. 73, yes, I want to make sure. And 75 does not. So the probability is going to be something out of 75. It's total outcomes. Well, we want the number favorable. So we have one number here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 out of 75. That can actually be simplified. Divide by 3. 7 over 25. Or actually, you can write this as a decimal if you want. This is 0.28 or 20%. I would write it as a fraction. Well, actually, yeah. Those wouldn't be accepted, but that's what the equivalence would be. All right. So we are in round 3, which is Algebra 1. And the first question is, for how many distinct integer values of x will the value of 12 over x plus 5 be a positive integer? The keyword is positive right there, because there are negative values. Now, you might be thinking, well, let's actually find all those values of x. You could, and that's fine. But what if I want to find how many values this will actually be as an integer? So let's let f of x equal this function, 12 over x plus 5. Well, 12 needs to evenly divide into x plus 5. Somehow, but we don't know. Well, let's check out the factors of 12. We could have 12 divided by 12, which is 1. You could have 12 divided by 6, which is 2. 12 divided by 4, which is 3. 12 divided by 3 equals 4. 12 divided by 2 is 6. 12 divided by 1 is 12. These values right here are really this, x plus 5. And you can actually solve for those values of x. But we don't need to do that, because we just have 1, 2, 3, 4, 5, 6 different denominator values. And the answer is just 6. So there are a total of 15 ducks and turtles in my pond. There are no other animals in this pond. If there are a total of 36 legs in this pond and all animals have the normal number of legs, how many more ducks and turtles are in my pond? And yes, I really do have a pond. No, I am just kidding. So this is just a system. Because we have ducks and turtles, we will let D equal ducks, T equal turtles. And I think you can kind of see where this is going. Because what we can say is that the sum of the ducks and the turtles is going to be 15. D plus T is 15. And there are a total of 36 legs in this pond. Well, ducks have 2 legs and turtles have 4. So 2D plus 4T is equal to 36. 2 times the number of ducks is going to be the total number of duck legs. 4 times the number of turtle eggs or 4 times the number of turtles is going to be the total number of turtle eggs. And that's going to equal 36. So this is the system, and I personally think the easiest way is substitution. You could use elimination or matrices if you really wanted to. D is equal to 15 minus T. Substitute in for D right here. So 2 times 15 minus T plus 4T is equal to 36. 30 minus 2T plus 4T is equal to 36. 30 plus 2T, 36. 30 is equal to, 2T is equal to 6. T is equal to 3. And we can use that to find the number of ducks. D is equal to 15 minus 3. D is equal to 12. So how many more ducks and turtles are in my pond? 12 ducks, 3 turtles. Answer is 9. Alright, so the equation of the line having an x-intercept 4/5 and a y-intercept 3/4 can be expressed in the form ax plus by equals 2, where a, b, and c are relatively prime and a is greater than 0. What is the value of a plus b plus c? Just a little refresher, relatively prime, this means that a, b, and c must not have a common factor except for 1. And a is greater than 0. This is just standard form of a linear equation. And you kind of know the points already of this equation. So if I draw a little coordinate plane, the x-intercept is at 4/5, which means right here, the point must be 4/5, 0. Same thing for the y-intercept. This is when x is equal to 0, 0, 3 over 4. And this is a line right here. So we know 2 points. Well, we can just find the equation. We can use slope intercept, point slope, whatever. So let's find the slope. The slope is the difference in y values. Well, I'll just write it like this: y2 minus y1 over not m2, x2 minus x1. So let's let this be 1 and this be 2. So y2 is 0, y1 is 3/4, x2 is 4/5, x1 is 0. This is really negative 3/4 divided by 4/5. We can keep change flip. This is going to be 5 over 4. Negative 15 over 16 is our slope. And we know it contains these 2 points. So we can just pick a point and we can really just write it in slope-intercept form, y equals mx plus b. Because we know its y-intercept is 0, 3/4. So this is really y is equal to negative 15 over 16x plus 3 over 4. And think about it, when I sub in 0, 3/4, you're going to get 3/4 equals 3/4. So this is true. So I'm going to go down here, and I want to get the x's and the y's on the same side. So I'm going to add 15 over 16x to both sides. 15 over 16x plus y is equal to 3 over 4. Well, we need them to be relatively prime. A is greater than 0. But to be relatively prime, they need to be integers. And that's important. You can't have fractions. Well, especially for these two. So I'm going to multiply by 16 because that will get rid of this denominator right here. So this is 15x plus 16y is equal to 3/4 of 16 is 12. And a is greater than 0. Check. What is the value of a plus b plus c? 15, 16 plus 12. 31 plus 12 is equal to 43. We are in round 4, geometry. So number 1, an acute angle has a measure of 54 plus 3x over 2 degrees, and all values of x lie in the interval from a to b. Determine the value of b minus a. So, and I probably said that after every question. So what? Have these words acute angle. And I'm sure many of you know, if not all of you, know that this is an angle between 0 and 90 degrees. So what do? We make this between 0 and 90 degrees. 0 is less than 54 plus 3x over 2 less than 90. If we really want, you can split this up. Or if you can deal with compound inequalities, that's fine. I'm going to just treat it as a singular, or two different inequalities. So 54 plus 3x over 2 is greater than 0, and 54 plus 3x over 2 is less than 90. Cannot be equal to, because then it would be a right angle. So solving this first one, 3x over 2 is greater than negative 54. 3x is greater than negative 108. Divide by 3. X is greater than negative 36. We don't have to switch the inequality sign because we're dividing by a positive, not a negative. Here, we subtract 54 from both sides. 72. X is less than 24. So, really, the interval from A to B is going to be from negative 36 to 24. When we sub in negative 36 and 24, well, guess what we're going to get? 0 and 90, which is really nice, and that's what we need to get. So, B minus A is going to be 24 plus 36, because minus a negative is going to be positive. Answer is 60. So number 2, a lot of words. Angle A is the vertex angle of triangle ABC with the measure B equaling x plus 6 degrees and measure C equaling 2x minus 54 degrees. The measure of B has twice as many degrees as the length of segment AB has inches. The measure of C has 3 times as many degrees as the length of segment BC has inches. Find the perimeter of triangle ABC. So, actually, what I forgot to mention, and this is really important, this is really isosceles triangle. So, my bad. And this is really important because we can kind of say, well, what sides are going to be congruent? So, let's do a triangle like this. A is the vertex angle, so basically that's the angle that is not congruent to the others. These two are going to be congruent, and these two sides are there, therefore be congruent. Measure B is x plus 6. Measure C is 2x minus 54. Sorry if you can't see that. So, well, these are the base angles, so they're going to be congruent to each other. So we can solve x plus 6 is equal to 2x minus 54. We can subtract x, add 54. X is equal to 60. And that becomes pretty important because, well, we can redraw this triangle. Oh, shoot. Knowing that x is equal to 60. So, this is A, B, C. So this is 60. 60 plus 6 is 66. This should also be 66, just want to make sure. 120 minus 54 is 66. So measure of A. Well, triangle angles are going to sum to 180 degrees. These two are 132, so this is going to be 48. And the measure of B has twice as many degrees as the length of AB has inches. So this is 66 degrees, twice as many as the length of AB, which is going to be 33 inches. I don't need the units because in your final answer, the little like line is going to say this is your answer, inches. Doesn't really matter, but if you want, why not? So the measure of C has 3 times as many degrees as the length of BC. Well, if C is 66 degrees, BC is going to be 22. Divide by 3. Well, then what's AC? This is isosceles, so these two sides are going to be congruent. This is 33. So the perimeter is just going to be the sum of all the sides. 33, 33, 22, it's going to be 88 inches. So number 3, an open box is to be constructed from a square piece of material by cutting out a 3-inch square from each corner. If the box is to have a volume of 363 cubic inches, what is the length in inches of a side of the original piece of material? So This is 3D geometry. Usually it's seen maybe twice or 3 times a year. I don't know if it'll be on the 2020 playoffs, but you never know. So the important piece is it is constructed from a square piece of material. So this is our starting point. From a square piece of material. So this is going to be a decent approximation of a square. Really, it's not. So a square, all sides are going to be the same. Let them all be x. What this is saying is that a 3-inch square is cut from each corner. So really, all of these right here are going to be 3 by 3 by 3 inches squares. So 3, 3, 3, 3, 3. I think you get the point. What this does is these will now be the heights of a box. If this is x, what happens if I redraw it? This piece right here is going to be x minus 6 because these are both 3. When we sum these all together, we're going to get this x. So this segment is going to be the total minus the sides that are cut off. And what happens is we can draw a rectangular prism now, and it will look something like this. So this is going to be x minus 6. This is going to be x minus 6. This is also now going to be 3. That is this height right here, or really here I should say, that is going to be flapped up. So this is my box, but these 3 inches that are cut off are going to go here. It's going to go up. So volume is length times width times height, and that's going to be 363. So x minus 6 times 3, 363. Let's expand this. If we divide by 3, this will equal 121. So x squared minus 12x plus 36, 121, x squared minus 12x. Oh, who knows what that's going to be. I got my solution key right here. I'm way too lazy to actually do this. 85 equals 0. So we want to sum a negative 12 product of negative 85. So x minus 17, x plus 5 equals 0. X is equal to 17 or negative 5. So we have 2 solutions. Well, is that possible? Well, absolutely. But in this case, can x be a negative value? Well, no, we can't have negative 5 inches. That is thrown out. 17 is not negative, so it has to work. So what is the length in inches of that side of original material? That side is going to be 17 inches. So round 5, Algebra II. This is where they might get a little tougher, especially for the upperclassmen. So number 1, if 1 root of x squared plus kx minus 27 equals 0 is the square of the other, what is the value of k? Well, we don't know what k is, and you might think, oh, maybe we can factor, maybe we can put the square quadratic formula, but we don't even know what those roots are. What we can do is denote the roots as some variable. So let's let the roots, let's let one of them be n. Why not? Without loss of generality, one of them is just going to be n. The other root is going to be n squared, because it's the square of the other. No matter what n is, the other one's going to be n squared. So what is the value of k? Well, we don't know. But we can use our sum and product of roots formula. We call these Vietta's formula. So for a quadratic, the sum of the roots is going to be negative b over a. For the product, it's going to be c over a. Well, look at c and look at a. We don't even have like something in terms of k. We just have negative 27. So the product, n times n squared, the product of these 2 roots, is going to be negative 27 over 1, negative 27. So n squared is equal to, or n cubed is equal to negative 27, n is negative 3. So that means the roots are going to be negative 3 and 9. And therefore, the function is going to be x plus 3 times x minus 9. This is how we write the factors. And we get x squared plus 3x minus 9x minus 27, x squared minus 6x minus 27. So k is going to be negative 6. Okay, so number 2, determine the constant term of the expansion of x minus 2 over x squared all to the 9th power. And I just underline constant term because it's a very important term to actually review. A constant term, it's constant. It is any numerical value without an x or a variable. It's just a number, like 5, negative pi, 628, whatever. So when we expand this out, we're going to get some constant terms, some numerical expansion. But do we really want to multiply this 9 times? Well, I don't think so. There was actually a problem very similar to this on the most recent meet, Rimmel Meet for 2020. And it used something called the binomial theorem. What this does is it gives us a certain term out of these 9. We only have to find one. We can do this 9 times. But what we can do is we can actually find the constant term through this binomial theorem. What happens is these two terms have to have an exponent sum to 9, meaning let's let an exponent equal r. Now this is probably really confusing, and that's fine. But what I want to do is I want to separate this. We're going to let this be x to the r power. Let's let x have some r that I'm raising it to. Well, the opposite has to also sum to 9. But we already know r, so this is really minus 2 over x squared to the 9 minus r, because it's summing to 9. I could have x to the 4th, and then to the 5th here. We don't know what that r is. It's an integer. We can actually rewrite this now as x to the r, negative 2, x to the negative 2, I'm bringing this up, to the 9 minus r. The constant term is going to be found when I eliminate these x's, when we just have a numerical value. So what I want to do is I just want to set equal to 0. I want the exponent of x to be 0, so it just becomes 1. So this is really r, then we have this, minus 2, 9 minus r is equal to 0. And I will just simplify, r minus 18 plus 2r is 0, 3r is 18, r is equal to 6. Now, what we are going to do is we are going to substitute it back into what we already have. So this is really x to the 6 times negative 2, x to the negative 2 to the 3rd, because 9 minus 6 is 3. But we are not done. We must put a binomial coefficient in front. And this is where the n choose r type of thing comes. And this is why we call it the binomial theorem. We are going to do it for a binomial, but we have to multiply it by with consideration of what this exponent is. So on the top, we're going to put 9, because that is the total exponent. On the bottom is going to be what we just found, that r, which is 6. And we're going to recall and choose r. Really, this is how many ways can I choose 6 from 9 total. That is what we're really finding. This is n factorial times n minus r factorial, where that factorial is the product of all integers from 1 to that value. So 9 choose 6, as we call it, is 9 factorial over 9 minus 6 factorial times 6 factorial times x to the 6 times negative 8x to the negative 6. Well, guess what? These cancel. Now we just have a number. And isn't that what the constant term is, as I just said? So we can simplify this by actually expanding out. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 over, 3 times 2 times 6 times 5 times 4 times 3 times 2 times a negative 8. So you can cancel that out, we can cancel this out. Well, we can maybe divide each by 2 here. You can divide each by 3 here. So what we have left is a 3 times a 4 times a 7 times a negative 8. So this is 12 times 7. This is 84 times 8, or negative 8. 84 times 8. 2 carry the 3, 67. Put the negative. Alright, constant term is negative 672. And if you actually want to put this into the calculator, you will see at the end, minus 672. And that 4a, b, and 18 are 4 positive integers, such that the first 3, 4a and b, form an arithmetic progression, while the last 3, a, b, 18, form a geometric progression. Determine the sum of a plus b. So the first important thing is positive integers. So if we ever get negative integers in our solutions, don't work. Second thing to note are these two terms, arithmetic and geometric. So if I actually write out 4, comma a, comma b, comma 18. What an arithmetic progression is that I can add some value, let's just call it r, such that this will actually hold true. It could be something like 1, 2, 3, 4, 5, or I don't know, 10, 8, 6, 4, 2. I'm adding or subtracting by that same value, really adding my negative 2 in that last case. A geometric progression is where I'm multiplying by some value. We'll call it r. Such as 1, 2, 4, 8, 16, 32, 64. It could also be something like 9, 3, 1, 1/3, 1/9, so on. Or really it would be 1/27, my bad. Something like that. So multiplying by some value. So that right there is just a little basic introduction to arithmetic and geometric. So really, 4a and b are arithmetic, whereas a, b, 18 are geometric. So really I'm adding by some r. And here I'm multiplying by some r. And again, the r's don't have to be the same. I'm just putting them as r. So really this a is 4 plus r, and this is 4 plus 2r, because I'm adding by some value r. What I can say is that these middle values are respectively the arithmetic mean and the geometric mean of the surrounding two values. Arithmetic mean is probably the mean you're just used to. You add the two numbers, divide by 2. So 4 plus b over 2 equals a. You can actually prove this by letting b equal 4 plus 2r, dividing by 2, you'll get 4 plus 2r over 2. Really, this is plus 4, because 4r plus 2. This will equal 8 plus 2r over 2, 4 plus r. And isn't this just 4 plus r right there? So, you can actually do it for this one too. The geometric mean, for two numbers, it's just the product within a square root. So, because I have two values, a and 18, really this is just saying the square root. There's two numbers, so it's the second root of the product, 18a. This is equal to b. And now right here, 4 plus b over 2 is equal to a. So, this is a little system here, and this is where it gets interesting. We get 4 plus b is equal to 2a. b is equal to 2a minus 4. Here, we can sub in root 18a, 2a minus 4, 18a, 4a squared minus 16a plus 16. I'm really just squaring both sides here. I just did it out. 4a squared minus 34a, 16 is 0. 2a squared minus 17a plus 8 equals 0. We can solve this however we want. I'm going to take a guess and say there's going to be some nice factors here. I actually do not know. I'll just get some room. It's probably going to be something like 2a, a. If we did like minus 1 minus 8, that works perfectly. Yeah. So a is 1/2 or 8. Well, do both of these work? And this is where that positive integers comes into place. If we sub in 1/2, we're going to get that b is negative 3. 2 times 1/2 is 1 minus 4 is at negative 3. But that's not a positive integer, so that actually can be excluded. So A is really 8. So the numbers are 4, 8. B would have to therefore be 12, comma 18. This makes sense. Plus 4 plus 4. This is times 3/2, I think. And yeah, so the sum of A plus B is 8 plus 12. So the sum is 20. Right, so given A, B, and C are complex numbers, and A equals 2 plus 3i, B is 7 plus 2i, and C equals 8 plus I, determine the value of A plus B when A minus B over C, capitals, is simplified and expressed in the form A plus BI. Just want to make sure it's right. Yes, it is. So, we're just going to simplify A, B, and C. Sub it in. So, this is 2 plus 3i minus 7 plus 2i over 8 plus I. Simplifying, we get negative 5 plus I over 8 plus I. This is not simplified because we have this complex number. We need to, if you want to call it rationalize, however you want to call it, get rid of that. We're going to multiply by its conjugate, which basically means I'm going to flip this time before the I. So it's going to be 8 minus I over 8 minus I. It's really multiplying by 1, which we can always do, but just in the form of 8 minus I over 8 minus I. So, we're going to do some little arithmetic here. Also forgot to mention, this is the first one in the Algebra II, Trig, and Conics round, which is basically the miscellaneous that we have now, except they put the 3 in all in one. Okay, so this is what you get, and you can FOIL this out. Negative 40 plus 5i plus 8i minus I squared over 64 minus I squared, because positive 8i, negative 8i will cancel. And we get, well, negative I squared, well, I squared is negative 1, so negative is positive. So this is really negative 39 plus 13i over, well, I squared again, negative 1, 64 plus 1 is 65. So this is really negative 39 65ths plus 13 65ths is I. And this actually simplifies really nicely because these are multiples of 13 right here. So this is really negative 3/5 plus 1/5 I. And we just need to find A plus B. So negative 3/5 plus 1/5 is equal to negative 2 over 5, or negative 0.4. Alright, so number 2 is determine all exact values of x in the interval from 0 to 2 pi, where you don't include 2 pi, but you include 0, for which 16 to the sine x power over 2 to the cosine squared x power is equal to 2 times 2 to the sine squared x power. Express your answer in simplest form. So, I'm noticing these all have bases of 2. This is a power of 2, kind of like the first one, arithmetic and number theory. We're kind of going to have to rearrange those bases, so they're all the same. So I'm noticing that 16 is really 2 to the 4th, and we can kind of do some stuff with that. So this is really 2 to the 4 sine x over 2 to the cosine squared x is equal to 2 to the 1st, because it's just 2, times 2 to the sine squared x. When I have like bases, I can add these together. When I have like bases, but I'm dividing, I'm really subtracting. So this is really 2 to the 4 sine x minus cosine squared x is equal to 2 to the sine squared x plus 1. And now we have these like bases, and guess what we're going to do? We're going to set these equal. Set these exponents equal. So we have 4 minus sine x minus, or really 4 sine x, and a minus sign there, minus cosine squared x is equal to sine squared x plus 1. Now here's the interesting part. If we add cosine squared x to both sides, we get 4 sine x is equal to sine squared x plus cosine squared x plus 1. And if you know your Pythagorean identities, sine squared x plus cosine squared x is just 1 for all x. So really, 4 sine x is equal to 2. Sine x is equal to 1/2. So think of our unit circle here. That y coordinate is going to be 1/2 right here. And if you really need to, you can draw your 30, 60, 90 degree triangles or 45, 45, 90 to actually figure out, well, when is x going to equal 1/2? But you will get, well, and I think you want it in radians because it has that 0 to 2 pi, that x is going to be pi over 6 and 5 pi over 6. And you can actually substitute in and see that this is true. Alright, so number 3, determine the length of the conjugate axis of a conic section with eccentricity 5/4 and focal points at 0, 19 and 0, -1. So, if you don't know anything about conic sections, or you might just be getting introduced to it, this word eccentricity is going to become very critical. Eccentricity is just a measure of how spread out, or really how stretched out, I should say, that a conic is. The more it's stretched out, the more that the eccentricity has to be. And you can actually use the eccentricity to actually define what conic section it is. And if E, the eccentricity, is greater than 1, for any eccentricity greater than 1, the conic is a hyperbola. If it's equal to 1, it's a parabola, and if it is less than 1 but greater than 0, it is an ellipse, and if it's 0, it is an ellipse. So nonetheless, the eccentricity is greater than 1, so it's going to be hyperbola. The eccentricity for any conic, though, is C over A. And you're probably like, well, what is C, what is A? I'm just going to set an equal first. C is really going to be something in terms of A, and also B. A is going to be the distance between the vertices. This is called your transverse axis. It's not the conjugate, it's the transverse. That's the distance between the two vertices. Purple might look something like this. This is your transverse axis. But we don't know what that is. We just know that the focal points are 0, 19 and 0, -1. And guess what? The focal points, the distance between the foci, well, the distance between the foci is 20. Guess what the actual distance is? 2c. For any hyperbola, it is equal to 2c. And this is going to be equal to 20. So c is 10. It is half of that distance between the foci. So, guess what we can also do? 10 over a is equal to 5 over 4. And we can solve for a. A equals 8. It is the distance between those vertices, which is 8. Well, great. That's the transverse axis. Well, what's the conjugate axis then? And that's where C is going to come in. C, in terms of A, well, for a hyperbola, it's going to be the square root of a squared plus b squared, just like Pythagorean theorem, where B is going to be half the length of that conjugate axis. And now, actually, my bad, the distance between the transverse is going to be 2a, not a. Now that I think about it, my apologies there. So, a is equal to 8, c is 10. So 10 is equal to 64 plus b squared. B squared is 36, b is 6. Well, so what's the length of the conjugate axis? 2b. Transverse is 2a. This is going to be your conjugate. 2a is going to be your transverse. So the conjugate axis is 2 times 6, which is 12. Alright, so we're in the relay round. So basically there's going to be a set of 4 problems, and you're going to use the answer from the previous problem for the next one. So number 1, we're going to let a hashtag b equal a plus b squared plus a, and c at d equals c plus d over 2, which is basically the average. And then you have to evaluate this whole entire thing. Is there a trick? Well, maybe, but there might not be. And that's fine. And I'm just going to tell you right now, there really is no trick. You just have to evaluate. This is an arithmetic problem. They put a lot of arithmetic in these playoffs. Or realize, I should say. So, take it one step at a time. We're going to do the hashtags first, just to make it a little easier. So, 2 hashtag 6 is equal to 2 plus 6 squared plus a. Or 2, sorry. Because think about it. 2 hashtag 6. A is 2, B is 6. So, wherever I see an A, I'm going to put 2. Think of this as 2 hashtag 6. 2 is right above the A, 6 is right above the B. It's like saying x plus y equals 10, x is 6, y is 4. You have those x and y's, kind of like here. So really, going back to this, 2 hashtag 6, we're subbing in A equals 2, B is 6. So 64 plus 2 is 66. 0 hashtag 2 is going to be 0 plus 2 squared plus 0, which is 4. 2 squared is 4. 5 hashtag 2 is going to be 5 plus 2 squared plus 5. 7 squared is 49 plus 5 is 54. And 3 hashtag 2 is going to be 3 plus 2 squared plus 3. 5 squared is 25 plus 3 is 28. So this whole thing becomes 66 at 4 at 54 at 28. This is just finding the average. C plus D over 2. 66 plus 4 is 70. Divided by 2 is 35. At 54 plus 28 is 82. Divided by 2 is 41. And then we just have to find the average of these two numbers. Their sum is going to be 76 divided by 2, which is 38. This is the answer to question number 1. Alright, so number 2. So we're going to let k equal TNYWR. That stands for the number you will receive. So we found out from number 1 the answer was 38. And we're going to use that for number 2. A regular polygon has interior angles that each measure k times the measure of each exterior angle. How many sides does the polygon have? Immediately, when you have this k, so you might even be working on it before, which you really should be, if you have time before. Sub in what you know for k. In this case, 38. So the interior angles each measure 38 times the measure of each exterior angle. So, we want to find the relation between one interior and one exterior angle. Well, okay, so interior angles. The interior, well, we want to find the sum divided by the number of sides. So this is really 180 times n minus 2 over n. This is the sum of all the angles. This is the number of sides. Kind of makes sense. Well, in a square, if I have the sum being 360 degrees, 4 sides, well, each one's going to be 360 divided by 4. Exterior, well, the sum of all exterior is going to be 360 divided by the number of sides for each exterior angle. So 360 over n. But interior angles are 38 times each exterior. So 180 times n minus 2 over n is equal to 38 times 360 over n. And well, here's the good thing. Each of these have the denominator n, so we could just add equal to each other. 180 n minus 2 is equal to 38 times 360. And this is where, yeah, it might get a little nasty. And you know what? That's fine. That is fine. If you can multiply this out, perfectly fine. And in this, really, they actually allowed a calculator because they used to have calculator. But we're going to multiply this out. Why not? Get rid of the 0. We'll put it back at the end. 38 times 36. 8, carry the 4. 18, that's going to be 22. Cross out, we get a 0. It's 24. 9, 11. 8, 6, 3, 1. 1368. So 1368, 0. We can actually factor out a 10 from both or all sides. Or, you know what the n says, it's this. So really 18n minus 36 is 1368. And then we gotta divide. And now the number of sides. 18. Well, how many times did we go into it? It's going 8 times. I actually don't know. Nope. So it has to go on 7. 7. It'll go on 126. 14, 4. And hey, look at that. 8. Right there. Goes in pretty nicely. So the answer is 78 sides. Alright, so number 3. So we established in number 2, the answer was 78. So number 3, the 5th term of an arithmetic sequence is 7 and the 10th term is 22. Find the kth term in this arithmetic sequence. So again, we want to sub in k once we know what it is. But I'm going to tell you right now, you can actually do a lot of this problem without knowing what k is. And then you can sub it in later. And that's kind of what I'm going to do. Ignore this for now. Just worry about this. To the left. So the 5th term is 7, 10th term is 22. So let's let this sequence be in terms of a and n. This is the 5th term, a5. This is 7. This is a of 6, a of 7, a8, a9, a10. I'm just doing this as a visual. The 10th term is 22. In that Algebra II problem I did earlier, well, in an arithmetic sequence, what's going to happen is we're adding by some constant. We will call it n. Doesn't matter what it is. This could be negative. Who knows? But, well, we're going from a smaller to a larger number, so it's not going to be. So really, we're adding 5 times. So really, 7 plus 5n is equal to 22. 5n is 15. N is equal to 3. What this means is we are adding by 3 each time we're going from number to number. So this is really this. So this is what we call the common difference. It's, well, what's the difference to each number? And it's common to all of them. So it kind of makes sense to call it the common difference. So we know that A5 is 7, D we'll call is 3. For an arithmetic sequence, the formula is A of n is equal to A1 plus D n minus 1 for some nth term. But we don't know what the first term is, A of 1. But we do know that the 5th term is 7 and each increasing term is 3. So A of 4 is going to be 4 because 7 minus 3 is 4. Think about it. When I add 3 to this, I'm going to get 7. A of 3 is 1. 2 is negative 2. A1, negative 5. This is the first term. So really, it's negative 5 plus 3 and minus 1. A of n equals 3 and minus 8. And we need to find the 78th term. So we're just going to solve in 78, obviously. 3 times 78 minus 8. Again, you can use a calculator or you can do it longhand. Well, nowadays you don't get a calculator. 226 is that 78th term. Alright, last problem. So let k equal a number you will receive, which we found from the last problem, to be 226. So after spending 1/2 of my money, then 1/3 of the remainder of my money, I now have k dollars remaining. So how many dollars did I start with? So I underlined 1/2 of my money that was already spent. So let's let x be the money that I started with. So 1/2 of my money spent is really saying x divided by 2. Think about it. If I have $10 and I spend half of it, well, I'm going to have 5 left. X divided by 2. Then 1/3 of the remainder, well, 1 minus this, or really x minus that, is going to still be x over 2. So this is really 1/3 times the remainder
well, it just happens that the remainder and the money that was spent are actually the exact same thing. And we have k remaining, and we know k is 226. So, x over 2 minus x over 6 is equal to 226. Well, we need a common denominator here, so this will be 6. So 3x over 6 minus x over 6 is equal to 226. So 2x over 6 is equal to 226. X over 3 is equal to 226. X is really equal to 3 times 226. Really 3 times k, what we started with, actually, kind of interestingly enough. So x is going to be, if I'm not mistaken, 678? I think? Yeah. So therefore, how many dollars did I start with? Well, x, $678. That is the final answer that you will pass in as part of your... Alright, so we are finally in the team round, and that's actually pretty exciting. So, number 1, determine the largest value of x for which that determinant is equal to 7x squared minus 74. So when we have a 3x3 determinant, one way we can do it is by focusing on matrices of minors. What that means is that I can take these 3 values and find the minors of that matrix. So what I do is I'm going to start at the top left one. This will always be positive. It actually goes positive, negative, so on. But since we only have 3, we only have to do positive, negative, positive. The fourth one will be negative, and so on. So really, we're going to start at this. Positive, negative 2. This is just negative 2. And then what I do is the minor of that matrix is going to be found by eliminating all values in the same row and column. So when I'm looking at this matrix, I want to get rid of these and these to get a matrix. And that will be x, 3, 1, 5. And we're going to find the determinant eventually. Now we look at the next coefficient. It's a positive 4, but we need to take that negative. That's that sign. Minus 4, determinant, we're going to get rid of all these and all these. Same row and same column, which is going to get 3, 3, negative 1, 5. And then the last one, that's going to be 0. Well, plus 0, and then same row, same column, 3x, negative 1, 1, is equal to 7x squared minus 74. Well, 0 times anything is going to be 0, so this actually can be excluded. Now we need to just find the determinants. So for any 2 by 2, it's going to be that AD minus BC. A, B, C, D. This product minus this product. So this is really 5x minus 3. 5 times, or x times 5 minus 3 times 1. Here, well, we don't have an x. We're going to actually get a numerical value. 15 minus a negative 3, so plus 3, is equal to 7x squared minus 74. And now we're just going to expand it out. Negative 10x plus 6 minus 60 minus 12 is equal to 7x squared minus 74. Negative 10x. This is really negative 54, negative 66. I think it's a minus 8. It's probably going to be 7x and x is equal to 0. Who knows what it's going to be? Well, it's positive, so it's probably going to be something greater here, like a plus, I don't know, plus 2 minus 4. Yeah, negative 4x plus 14 is going to be positive 10. You could use the quadratic formula to ensure. So you get x is equal to 4 sevenths, or negative 2. Well, we want the largest value of x. So I think you all know that the larger value is going to be 4 over 7. Number 2, solve for y. Y to the y power plus 2y times y to the y minus 1 is equal to 768. I mean, you could test in values. This one actually does come out pretty nicely. But we're going to actually prove that these are the actual solutions. These are the only solutions.
So, I'm looking at this especially because it has that compound here, y minus 1. Not just a y, not just a 5, y minus 1. And we can actually split this up kind of nicely. This becomes y to the y plus 2y. And now if we break this up, well, this is really y to the y times y to the negative 1. Because I'm really adding these up, again, if you think about it. If I wanted to combine with the same base, is equal to 768. So this becomes y to the y plus 2y times y to the y times 1 over y is equal to 768. And this simplifies. We can cancel out a y here, a y there. So now we really get y to the y plus 2y to the y is equal to 768. 3y to the y is equal to 768. Y squared is equal to 256, I think. Yeah, I think it is. Or not y squared. Y to the y. I'm stupid. My bad. And now there's not really an algebraic way, but if you test in integer values, you'll actually see that y is equal to 4. Because 4 to the 4. You could actually try using logarithms here, but I'll show you it doesn't really do a whole lot. Y to the y is equal to 256. If we take log base y both sides, we can bring this y down. So y log y to the y is equal to log y 256. And then we get y is equal to log y 256. And you can't really do a whole lot, because if you try to reconvert it to an exponential, you're just going to get this. But regardless, what you do get is that y is equal to 4. Number 3. Find the area of the triangle ABC if AC equals 4, BC equals 6, and cosine 2C equals negative 1/3. Express your answer in simplest form. Meaning if we ever get a radical, simplify the radical. Notice how there's no bar over the AC and the BC because we were talking about length. That's very important. I know some of you may not have known that. So, again, when I've told you this before, I'm going to tell you it again. Draw out the diagram. I don't care if it's to scale or not. It helps usually if it's to scale, but I don't care. I'm just going to draw a kind of equilateral triangle. A, B, C. AC is equal to 4. BC is equal to 6. Cosine of 2C is equal to negative 1/3. And express your answer in simplest form. Well, if we remember the area of a triangle, including trig, we know that area is equal to, for any two sides A and B, and included sided C, 1/2 AB sine C. Really, this is the vertex B, so the opposite side is really B. This is vertex A, so the opposite side is really A. This is really C. We know that cosine of 2C is negative 1/3. But that's this angle. We want to write sine of something. We want to find sine C. So find sine C. So we can use a double angle identity. We know that cosine of 2C is equal to 1 minus 2 sine squared C. That is an equivalent form. There's actually two others, but this is the one that only includes sine. So 1 minus 2 sine squared C is equal to negative 1/3. We're going to add 2 sine squared C to this side, add 1/3 to that side, and we get 2 sine squared C is equal to 4/3. Multiply by 1/2. This should be 2/3. Now, this is the tricky part, because if we take the square root of both sides, we get plus or minus 2/3. And
this is actually where it gets a little tough because, well, do we use the positive value or the negative value? And this is where you have to really think. When we have an angle, we're always thinking from 0 to 180 degrees, otherwise it's not a triangle. In the first and second quadrants, sine is always going to be positive. If you've learned trig, you will know ASTC. All science teachers are crazy. All students take calculus. This shows what trig angles are positive in which quadrant. All of them are going to be positive in the first quadrant. This is just talking about sine, cosine, tangent. This actually works for the reciprocals. So the reciprocal of sine is cosecant. That actually works for that too. This S is sine, this is tan, and this is cosine. Really, it should just be this. Sine will be positive here, tan will be positive here, cosine will be positive there. So no matter what the measure of C is, whether it's acute or obtuse, it will always be positive. So sine has to actually be positive, 2/3. So the area is 1/2 times 4 times 6. And actually I have to take the square root of that, my bad. Sine C, which is root 2 over 3. But we want to rationalize that. So root 2 over 3, well, if we multiply by root 3 over root 3, you get root 6 over 3 times root 6 over 3. And we can cancel out a little bit here. You should get, and this can also cancel out, and we should get the answer to be 4 square roots of 6. Unit squared if you want, but on the answer sheet, they'll probably have the unit squared already for. The probability the Mariners win any baseball game is 2/3. What is the probability they will win a 7-game series in 6 games? Note, to win a 7-game series, a team must win 4 of the 7 games. Once this has happened, no more games are played. Express your answer as a fraction in simplest form. Now, this looks really complicated. Trust me, at first this even stumped me, and that's perfectly fine. But we need to, again, take it one step at a time. They are playing 6 games, and they need to win 4. So, I'm going to label out these games. 1, 2, 3, 4, 5, 6. Game 1, Game 2, Game 3, Game 4, Game 5, and Game 6. I'm going to put a check mark for everyone they win. Well, if we're winning in 6 games and not 5 or 7, well then they must have won the 6th game. They had to, because if they hadn't won that game but won the series, then they would have maybe done it in 5 or 4. That means they have to win the last game. So they need to win 4 others. 3 others. So we need to have 3 other wins of those 5. But those 3 could be any of those 3 out of 5. It could be these 3, could be these 3, these 3, these 3, we don't know. So what we're going to do to determine the number of ways is we're going to use a binomial coefficient, which is that n choose r. 5 choose 3. That is telling us how many ways can I get 3 wins out of 5 total. Doesn't matter the order. And this is 5 factorial over 5 minus 3 factorial, 3 factorial. We can actually evaluate this out. So this is 120 over 2 times 6, and this is 10. So really 10 times whatever the probability is. Well, they won 4 games out of the 6. So 2/3, the probability they win is 2/3, 4 times. Well, what about the other 2 games? They must have lost, and it's fine if they lose too. Meaning we need to take the complement. The probability they win is 2/3. So the probability they lose is 1/3, because 1 minus that 2/3. So really we need to do 1/3 squared. They lost 2 games, each of a probability of 1/3. We can't just exclude those 2 just because they didn't win. And we get 10 times 16 over 81 times 1 over 9.
this is going to be something over 729. This is 160. And this is a pretty big fraction. And according to the answer, it actually is a simplified fraction. And I guarantee you there's plenty of teams that probably check to see, oh, are there any common factors? And could I simplify? There actually aren't. And this was actually a non-calculator round, so you really couldn't do anything like that. Usually the fractions won't be this bad in meets, but it's really important that you check if you get this. Usually there's nice answers, but in this case, not always. Alright, last question. So if log base 3 minus x of 3x cubed plus 3x squared minus 31x plus 27 equals 3, find the sum of all possible values, of 2x plus 9, choose 7 minus 2x. This is that choose, that and choose R. That's what we just did, and they apparently loved this during the playoffs. So, well, we kind of need to solve this first, before we can get to this. So, converting to an exponent, we're going to take the base, raise it to the answer, and set it equal to this. That's how, that we're just converting from a log to an exponent. So, 3 minus x cubed is equal to 3x cubed plus 3x squared minus 31x plus 27. So this is really 3 minus x, 3 minus x, 3 minus x. I'm just going to simplify this first. You get 9 minus 6x plus x squared, 3 minus x, 27 minus 9x, minus 18x plus 6x squared, plus 3x squared, minus x cubed. So we get negative x cubed plus 9x squared minus 27x plus 27. I'm just going to copy it there to save some room. So, negative x cubed plus 9x squared minus 27x plus 27 is equal to 3x cubed plus 3x squared minus 31x plus 27. And well, we're saying it equal to both sides. We're saying it equal to each other. You can cancel out the 27s because, well, subtracting them is just going to cancel. And just bring everything to one side. So adding x cubed, 4x cubed, subtracting 9x squared, minus 6x squared, adding 27x, we get minus 4x is equal to 0. Well, we can divide everything by 2. That might actually help a little bit. 2x cubed minus 3x squared minus 2x is equal to 0. X, we can factor out. 2x squared minus 3x minus 2 is equal to 0. X, this is probably going to have some interesting factorization. X, is equal to 0. Let's try minus 2 plus 1. Yep, that works. You can use quadratic formula. So basically, x is equal to 0. X is equal to negative 1/2. X is equal to 2. And as I've said, before we can just substitute in, especially if you're in Algebra II or above, you should know this. Make sure to test for extraneous solutions. They might not work. And this is definitely an Algebra II based problem. So, we need to sub in. Do all of these work? Well, when x equals 0, we get log base 3. This is going to be 27 equals 3, and that does work. Well, when we get negative 1/2, well, I mean, we're going to get a legible base here. I'm going to assume it works. Kind of looks like it will. But here's the one that causes a little problem. When we sub in 2, we're going to get log base of 1. But can we really have a base of 1? Think about it. Log base 1 of a number is equal to x. This doesn't really exist. Think about it. Because when we do change of base, we're going to get log, well, we'll call this y, log y over log 1 is equal to x. If we let the base be 10, because that's what the common log is, 10, log base 10 of 1, well, this is really 10 to the n is equal to 1, n is 0. Correct? Because literally anything to the 0th power is 1. So really, this is log base 10 of y over 0. And as you all know, we can't divide by 0. So it doesn't work. So this can actually be excluded. But we do have x equals 0 and x equals -1/2. So I'm going to erase all of this so we can actually calculate. So, when we sub in 0, oh, that's my eraser, you get 9 choose 7. When we sub in -1/2, we're going to get -1 plus 9 is 8, choose 7 minus 1, so 7 plus negative, or minus -1, that's going to be 8. 8 choose 8. Well, this one kind of looks easy. How many ways can I choose 8 from 8 total? Just one. You just pick the 8. 9 choose 7, well, this is the same thing as what I've done before this. 9 choose 7, which is 9 factorial over the difference factorial times the bottom factorial. And we can actually expand out that product, or you can actually find 9 times 8 times 9 all the way to times 2 times 1. I don't think you'd want to do that. So this is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 over 2 factorial, which is just 2, and then times 7 factorial, 7 times 6 times 5 times 4 times 3 times 2. The only reason why I'm not putting in a 1 is because, well, multiplying by 1 is not going to do anything. It's just multiplying by itself. Cancel all that, cancel all that. Well, we get 72 over 2, which is going to be 6. That is 9 choose 7. So the total, all the sum of the possible values, so the total slash sum is going to be 36 plus 1. Final answer is going to be 37.
Thank you so much for watching. If you've gotten this far, I really appreciate it. Leave a like, comment, and subscribe, especially for those on the math team. If you really liked this, let me know if you want me to do more. I really don't want to overdo like videos over the break because I have to do work myself. As a full IB student, yeah, nice perks about that. But again, I really hope you enjoy. Hopefully all of you can stay safe, and I will see you guys next time.